This new video will continue our emphasis on how we can teach geometric algebra and how we can teach its application, or how to apply it, I should say, to subjects such as physics. And I'll just briefly show a little bit of this article by Reddish. It's a bit of an older article, but it's quite concise, and many of the things that he presents here were presented at greater length in a series of articles that I treated in an earlier video, which I will link in the upper right-hand corner. So Reddish emphasizes that math, as we use it in physics, is used quite differently than in math classes. And I'll let you take a look here at the abstract for a moment, and then another brief highlighted passage that I think will be quite instructive. So go ahead. And here's the highlighted passage that I mentioned. So especially the part of how we put meaning into the symbols in physics, and the difference between how we do that in physics as opposed to in pure math classes is quite revealing. So I hope that you'll take a look at his article. The other article that I want to bring to your attention is this one. Pardon, I'll blow that up a little bit here. The effectiveness of activation of prior mathematical knowledge during problem solving in physics. Now, I've used this idea of activating prior knowledge in many of the materials or teaching materials that I've uploaded or written on geometric algebra. But these authors show how to do it in a much more focused way with a better idea of what exactly we're trying to do and how. So I'll take you down to a section here, and I'll blow that up a little bit more. If you'll take a moment just to read that. The article by Reddish that we looked at earlier emphasizes the difference between how math is used in physics versus in math class. This article shows how to help students apply what they do learn, the skills and such, in math class to physics problems, which is quite a difficult thing apparently for many students. So continue reading that a moment. And it's continuation of that section on the next page here, the blue. Pardon, I need to reduce that a little bit. Okay. So you may recall, or many of you will have known for years, that one of David Hestena's motivations for geometric algebra and what he wanted to accomplish was have an integrated math and science program at the high school level to begin with that is based upon geometric algebra. So this is something that, or this idea in general of integrating the math and science using a standard notation, which you'll notice here, is something that is highly desirable and that's recognized by many people. Now, geometric algebra, as many of us believe, is quite, well, perhaps unique or uniquely qualified to do exactly that kind of a connection. The thing is that it will be quite different in its approach and symbols and such from what students will have seen previously. So the idea here of how we go about improving math proficiency in general is somewhat more complicated when we're trying to develop proficiency with geometric algebra. But these authors offer several suggestions as to how that might be done, and their suggestions are not for geometric algebra, but are highly applicable to it, I believe. So we have these 5 interwoven strands of adaptive reasoning, conceptual understanding, procedural fluency, productive disposition, and strategic competence. That's 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 common to all problem solving. But concerning algebra education, the second one here, conceptual understanding and procedural fluency, very much an issue with geometric algebra since it will be new to a lot of students. So if we go down here to this next highlighted passage, I'll let you take a look at that for a moment also, and I'll see if I can blow that up a little bit more for you. Sorry, I overdid it. I hope that will be good enough. There's this thing that I think we've all developed who've used math very much, even though we may not do it consciously, is the idea of switching between looking at an expression as a whole in this what they call a gestalt view and looking at its details to see what we might be able to do with it. So as these authors note further on here, let me see if I can find it. Yes, this or what the authors propose is in the course of presenting problems in a textbook, many times we will find it useful, the students will find it useful, which is our main concern, that we activate prior mathematical knowledge, things they've learned in math class, that they may not recognize as being applicable to the problem at hand in a physics class. So there's this use of systematic hints at the start of a task, and also just smaller hints of, maybe little math tricks, or I shouldn't call them tricks, little math techniques to apply. And again, this is something that I've done in a lot of the things that I've prepared for self-learners and newcomers to geometric algebra. But these authors do it in a much more structured, coherent way that I think will be helpful. So I will leave the links to these articles in the video description, and I hope that you'll take a look at them. Thank you for your time.